Good morning and welcome to session 2 of our Signpost Assembly this morning. My name is Seamus Kearney. I am a specialist with the Signpost programme, and again, thank you for logging in such numbers again this morning. We had a very good session yesterday evening with our director, Professor Frank O'Mara, and head of the Signpost programme, Dr. Tom O'Dwyer, and they went through a lot of practical tips that farmers and partners could be looking at in 2022 to help increase farmer profitability and reduce emissions at farm level. So we're blessed here this morning with our panel, some of our colleagues within Teagasc, and very apt panel this morning looking with fertiliser prices looking the way they are for 2022. So we're joined by David Wall, William Burchill and Patrick Forrestal, and we're going to look at the whole area of fertiliser use for 2022. Patrick is going to look first of all at soil fertility, David's going to look at soil fertility first of all. William is going to cover the whole area about making better use of slurry at farm level, and Patrick is going to go through the fertiliser type use on farms for 2022. So I hope you enjoyed this morning's presentation and that you'll get a lot of tips and tricks for your own farms for 2022. So we're going to start the morning in a presentation format, and I'm first going to hand over to Dr. David Wall to go through his presentation on soil fertility and the importance of getting soil fertility right as the basis for 2022. So David, over to you.
Thank you, Seamus. Good morning, everybody. As we know, there's potentially a challenging year ahead in terms of fertiliser price, but maybe also supply. We'll have to see as the year goes on. We want to provide, I suppose, some tips here this morning in terms of successful soil fertility management, which is good for your pocket and for the environment. So without further ado, let's get into it. Just to set the scene a little bit, in terms of national soil fertility trends, if we look at pH here, we're looking at the soils in the figure or in the graph over the years 2007 to 2020, and the proportion of soils that are tested that have optimum soil fertility levels. So those are soils with a pH greater than 6.2 or above. And as you can see there, from about 2007 to 2015, we were moving along where we had between 30 and 40% of soils in the country. That's only 30 and 40% of agricultural soils at the optimum pH. However, in the last 4 or 5 years, this has changed very quickly, I would say. More lime has gone out this year. We'll probably have about 1.1 million tonnes. So we've broken the 1 million mark, and approximately 60% of our soils are optimum at the moment. So we have a little bit more to do in that respect. One thing that we can learn from is the past, and what I'm showing here is the fertiliser use survey between 2005 and 2015. And you'll ask, why am I showing that? And the reason is, we've been here before. We've had high fertiliser prices spikes in 2008, 2009. Many of you will remember that. And what happened as a result of that? You can see there, can urea, phosphorus and potash prices skyrocketed in that year as well, maybe not quite as high as they are currently. However, in terms of fertiliser use, which I'm showing here in the graph, the phosphorus graph, if we look at that, use fell from, on average, 8 to 9 kilos down to very low levels between 2006 and 2012. For phosphorus and also for potash. And you can see there, we weren't even achieving maintenance levels for either dry stock or for dairy, which had a knock-on effect. If we look at the corresponding soil fertility levels, phosphorus levels, and I'm showing here the index 1 and 2 soils for both phosphorus and potassium. So basically those low levels, low soil fertility, and those levels where you're going to run into a crop deficiency depending on yield targets, etc. And you can see there the number of low fertility soils increased corresponding to the low levels of use. It's only in the last 2 or 3 years that we're beginning to correct this, and the level of suboptimum soils is going back down. And I suppose we want to learn from the lessons of the past. There's many people talking about leaving out P and K and just buying nitrogen this year, but we want to be careful in terms of the long-term effect of taking that strategy. So why build soil fertility? Why bother at all? Looking at the figure here, we have soils across the 4 different indexes, 1, 2, 3, and 4. You can see there in terms of the dark green bar, And also, I would say the high fertility, the red bar there, in terms of relative fertiliser use efficiency. So this is the recovery of nitrogen fertiliser that we're putting out. And if we set those index 3 at 100%, how do we fare if we're operating at low soil fertility? So very low and low there in the yellow and the light green bar. And essentially what's happening here is we're wasting up to 15% of the nitrogen that we're putting out. It's not being utilised. It's going to be heavy on the pocket. And in a year like we're facing into going forward, this is not a sustainable future on a price point, on economics, but also in terms of the environment. So if we increase our soil fertility, we have many benefits here. Early season growth, the most precious grass to feed the livestock as we turn it out. Sward persistence, so the hard work that's going in there in terms of reseeding, we get longer from those, which has benefits in terms of carbon, as well as soil fertility. More resilient grass growth in terms of changes in weather. We could see in the drought where potash was corrected in fields, those fields were more resilient to keep going and growing something through the drought. And I suppose long-term environmental sustainability and profitability on top of that. In terms of optimizing soil pH, this is certainly the first action, the first option that somebody should be considering in the year ahead. There has been a lot of lime has gone out in the last 3 or 4 months. However, if you get your soil tests and you pull out your soil tests that you have, the new ones, or go back to the old ones that are still current, remember those soil tests last for a 4 to 5 year period, pull them out and see where the pHs are low. If you're below 6.3, you need to consider spreading lime. Lime price hasn't changed. It's just a matter of planning the year ahead. If we look at the figure here in terms of optimum soil pH, that's there 6.3 or above. These are data from real farms. It's the paddocks in each farm, and we're looking at the grass yield on the x-axis, on the y-axis here down the side. And you can see there, by optimizing the pH, we're getting to 4 to 5 tons of extra dry matter. Real farm data, that's worth a lot of money and pays for the lime on about a 7 to 1 return on investment. Other benefits in terms of lime. This is a recent study, hot off the press, that was conducted at Johnstown Castle, where we limed soils to different pH levels. So you can see there the red bar has very low levels of pH, 5.1, quite acidic. And as we increase up to the green and the brown bar there, where we come into the optimum range, we looked at the greenhouse gas output in terms of nitrous oxide. And you can see there, by increasing the pH, we get the double dividend. We get the extra benefit there of reducing the greenhouse gas level, nitrous oxide in this case, by between 22 and 40%. So there, you're getting that for free. That's more nitrogen potentially in the system for longer, which you can utilize going forward. There's also evidence emerging there in terms of increase in pH and storing more carbon in soils. And that's something that we're working on at the moment, and we will have data and research coming out on that in the very near future. Overall then, if we think about building good soil fertility, it does drive nitrogen recovery, very important for the future, especially in the year ahead in 2022. If we look here at data coming in from 21 farms, about 446 paddocks were tested over a 2-year period, and we looked at the nitrogen recovery from the swards. You can see there at very low pH, P and K levels, so the red dot there, we're getting somewhere between 25 and 30% recovery of the nitrogen that we put out. That's surely not sustainable, especially at a high price year, but even leaving price out of it, just recovering 25 to 30% of the nitrogen that we put out is not the future, can't be. If we increase pH alone, we increase that, we essentially double it, and that brings us up to somewhere around 45, 50%. However, if we, over the longer term, work on getting the pH, the P and K level correct, we can see there we're increasing that nitrogen recovery by greater than 30%. So we can double the level of recovery by just fixing the soil fertility in the ground. We haven't asked these farmers to change one other thing. So that is a compelling argument, I think, in terms of correcting the soil fertility, increasing the nitrogen use efficiency and getting the benefits there in terms of production, in terms of economics, and in terms of the environment. Moving on then, if we briefly touch on what we're going to do in the early season. My colleagues that are going to present after me are going to get into more detail on this. But if we think about the early season and the levels of growth that are happening, here I'm using data in terms of grass growth figures. And if we think about the nitrogen required to grow that early grass, how much demand is really out there? We have lower growth rates. We have higher variability in terms of years. We have soil temperature and moisture controlling these growth are too low or maybe too wet in some parts of the farm. And essentially what we're saying there is the total nitrogen uptake is low, and consequently the nitrogen that is required and the nitrogen that we put in should be tailored according to the demand. And you can see there over the last 3 years and in the long-term average, somewhere between 11 and 16 kilograms of nitrogen has been taken up there between early January and about the 1st of March. So again, it's about cutting our cloth according to measure and putting out what we need rather than overdoing it this year. Apply to drier soils first. There's a better response with a moderate grass cover out there. Utilize some slurry. Leave the fertilizer where it is in the first round. Maximize that benefit. But what I would say is don't put out too much because there's not a demand. And then we can always come back and apply to remaining soils. Again, very briefly, avoid cold, wet soils. You can see here in terms of the graph, as the temperature increases, the fertilizer recovery increases. And when we're down in that low 5 to 7 degree soil temperature, we're only getting about 25%, about a quarter of the nitrogen is being recovered. Finally then, if we get into what happens when the soil is damaged, we need to be aware that when soil is wet and we're going out with heavy machinery, we can do damage and that can have a long-lasting effect. What we're looking at here is the effects of compaction according to different soil moisture levels. At low soil moisture levels, you can see there the grass recovery and the grass growth was reduced there to somewhere between 40 and 60% of what it would be when we're traveling with the same machinery in the summer. So again, just be careful, watch your fields, look at your farm before you decide to go. Okay, in general then, just some take-home points. Your soil is your most valuable asset. Measure and manage. When I say measure, use the soil test results to make the decisions. Apply lime as recommended, and manage your soil fertility over the longer term to improve your environmental and your economic sustainability in the long run. I wish you every success in the year ahead, and I will leave it at that. Thank you.
Thank you very much, David, for your presentation. Just to remind you on the Zoom function on the computer as you're watching, if you could, any questions you have, to use the Q&A function at the bottom of the screen, especially with such expertise here with us, to be frightened not to use them this morning. So I think the big message that David's given us this morning is we've been here before with high fertiliser price. We'll bring that up in the conversation in a minute, how to best use it. We were going in the right trend with lime. And I think really what David is looking for this morning is a white Christmas is what I'm taking out of it. There's no such thing as overusing lime. So our next presentation, we're going to go to Dr. William Burchill. William's going to go through making better use of slurry, timing and how to apply it for 2022. Such a valuable fertiliser to have on every farm at our disposal at the minute. So how to make best use of it and cut down chemical fertiliser use on the back of it. So William, over to you for your presentation.
Thanks very much, Seamus, and good morning, everyone. So I suppose, as David alluded to, fertiliser price has gone up, and with that, the actual value of the slurries, the farmyard manures that we have on our farms has increased as well with that. And for an example, 1,000 gallons of cattle slurry now is valued at €39 per 1,000 gallons, which is essentially doubled over the last 12-month period. So we have a range of different nutrients within the farmyard that we might have already. Like for example, we have our liquid slurries. We also have as well our soiled water. And I suppose one important thing regarding soiled water is that it can deliver up to 4 units of nitrogen per 1,000 gallons, which is, quite substantial and can be used to replace and offset some nitrogen. Typical cattle slurry will deliver around 9 units of nitrogen per 1,000 gallons when it's sprayed with a trailing shoe dribble bar in the springtime. And the fact that soiled water is so watery, it generally gives us higher nitrogen efficiency. About 80% of that nitrogen is utilized, whereas typically with our normal slurry, higher dry matters, they'll give us about 40%. So as well, I suppose when we're looking at our slurries, and how we're going to manage them this year going forward, we have to look at, well, where is the most value we're getting from our slurries? Where has it the most nutrients? And if we look at typical cattle slurry, about 75% at the moment, based on current prices, 75% of the value of cattle slurry is coming from our P&K. So when we're making decisions on our farms, we must be conscious of that, because a lot at the moment we might be thinking that we need to use slurry to replace nitrogen, but the value of P&K, we must not forget about that. Also as well, look, there could be some other sources of P&K and nitrogen in the regards of kind of dry manures or farmyard manures, boiler litter, layers litter as well. They also have high in P&K contents and can be used as well to replace nitrogen. So with that in mind, look, the first thing we need to do within our own farms is to know what's in your own slurry. That really is going to be vital, and I think it should be a good target for all Signpost farmers to know exactly what's in their slurry. So typically within Teagasc, a number of years ago, there was a large study conducted where we looked at and went out onto farms and measured the nutrient contents of slurries, cattle slurries. So standard Teagasc values would be around 9 units of nitrogen per 1,000 gallons for springtime and using less, and about 5 units of P and 32 units of potash. And that's a value that, advisors and you would have heard a lot down through the years, okay? Last winter, we went out and we took a cohort of dairy farms in discussion groups, and we measured a large number of slurry samples again, just to get an updated value on that. So again, these are the results came back here as listed there as the Teagasc Dairy Gold Shine Programme samples. There's 128 samples taken, and you can see, look, they vary slightly from the standard Teagasc values that have been there. But one thing we did as well is we surveyed the farms and we looked at, what was the different type of slurry coming out of different types of tanks within the yards. So we looked at covered tanks, and you can see here, the slurry dry matter was slightly higher than the average, 7.3 dry matter. Thicker slurry had a slightly higher nutrient content. Then we looked at open towers. There was 9 samples taken here. Slurry, nitrogen, phosphorus, and potash was slightly lower on these. And as we go down to open tanks and lagoons, you can see as the tanks were more open, there was more water coming into them, they were less dilute, and as the more dilute your slurry becomes, the lower the in P&K content will be. So this really kind of shows that, depending on where your slurry is coming from, depending on how it's managed, what level of water is getting into the tank, what can be actually in the slurry tanker when you're driving out to the field can be very different, okay? So that really emphasizes what you need to do. So if you are going to get your slurry tested, these samples cost around 50 to maybe 80 euros a sample. If the slurry, your management of your slurry does not change year to year, these samples can be very relevant for a long number of years, maybe 4 or 5 years. Now, when you're going to take your slurry samples, look, first of all, number 1 is health and safety. Evacuate and ventilate before you agitate, and be very aware of that. Make contact with your local laboratory. There's a large number of labs throughout the country that are testing slurry samples. You can always contact your local advisor to help you with this as well. And the best time to sample your slurry will be kind of in that January, March period, the first time you come to spread slurry, okay? Agitate the slurry, mix it up well, make sure the crust is well mixed with the liquid underneath. Collect maybe a half a litre to a litre of slurry and post it or deliver it to your lab the same day, okay? So Also, alternatively to that, you can use a thing called a slurry hydrometer. What the slurry hydrometer does is it measures the dry matter of your slurry. And the dry matter of your slurry will tell you a large amount about in P and K content of the slurry. So you can use that. You can also order these slurry hydrometers are not available off the shelf in Ireland at the moment, but they can be easily ordered from a number of suppliers in the UK. Well, a number of farmers have ordered these and are making good use of slurry hydrometers to get a better handle on the nutrient content of their slurry. So okay, so you go and get your slurry tested, and now what changes are you going to make then based on the back of that, okay? So if we just take a standard Teagasc value for a slurry, and we apply 3,000 gallons per acre, this is what it'll deliver in terms of N, P, and K. Our requirement for first cut silage is 100 units of nitrogen, 16 units of P, and 100 units of K. So we can see there that 3,000 gallons to the acre of that type of slurry will deliver pretty much all the P and K that you need. We're topping up then with nitrogen and sulfur. If we look at, say, cover tanks from the current study that we had, it's a similar enough situation. It's delivering all the P and it's delivering the most of the K as well. But when we get into a situation where we have open tanks or lagoons, you can see that, there's a lot less nutrients in them. If we're applying the same application rate from an open tank, we're only delivering around, say, 69 units of K, or with a lagoon, it might be only 51 units of K. And that's going to leave us well short in terms of growing our silages. So maybe a thing we might be looking at within our own farms is that if we have covered tanks, that'll generally have good slurry content in it, get them tested, that will be good for silage ground. Whereas maybe more of our open type tanks or our lagoons, that might have a better balance in terms of applying our 23 units of nitrogen in that kind of January, February period, as a general recommendation based on if we have good growing conditions at those times of the year. So this shows the power of getting your slurry tested and knowing what's in it, because it's allowing you to match your slurry application rate and where it's coming from to the right field, and also in terms of growing the right crop, whether you're growing a crop of silage or whether you just want to supply a bit of nitrogen for growing a bit of grass at the start of the year. So, and as well, one thing we can't get away of, fuel costs will be higher this year as well. And, sometimes people are reluctant to move slurry to the silage ground. Well, if we just look at it, if we were to put out our full fertilizer requirements for first cut silage with all bag fertilizer, that's going to cost around €205 an acre to do this coming year. And you can see in the red boxes there under each of the slurries, that will be the corresponding cost to do that, where you put out that 3,000 gallons of slurry out on those fields, okay? So you can see, it can significantly reduce the cost of fertilizing your silage crop, and a bias that there will be higher contractor charges to move the slurry. So then as well, something you need to be aware of as well is that, at a price of nitrogen coming in at, say, if it's 23 units of nitrogen coming in at €25, that'll be 50 acres. 50 acres will, if you can replace nice slurry with 50 acres, that will mean that it will reduce your fertilizer bill by €1,250. So in terms of maximizing slurry, so as I said, the P and K value is at the highest value on your slurry. So use your soil samples, have your farm maps, and apply your slurry where it needs the P and K the most: the silage ground, where surplus bales are removed, and the lower index ground. To maximize your slurry nitrogen, we're talking about spreading slurry in the springtime using a trailing shoe or a dribble bar. As you can see, if we move from spreading with a splash plate in the summertime, that will give us 3 units of nitrogen, whereas if we move to the springtime with a trailing shoe or a dribble bar, that'll give us 9. That's a 6 unit of nitrogen increase in the value. And as we can see from the trailing shoe and dribble bar, there's a lot less losses of nitrogen associated with that. So as well, in terms of having a plan, so we know we need to get the slurry out in the springtime with a trailing shoe, because that will give us the best benefit. But in order to do that, we do have to have a plan going forward and have a plan for next spring regarding how we're going to get that slurry out. So what I would be advising is to use your slurry on the lower covers in the earlier season, that mid-March, mid-January to mid-1st of March period. That will more than enough supply enough nitrogen to grow your grass, as David alluded to, till around the 1st of March. The requirement is not that high. Then after we've grazed some of our medium covers first, after that we can start following stock with our slurry to also help us to reduce our fertilizer and our fertilizer on those particular paddocks. So all I'd say is set aside your slurry, strong slurry for the silage ground. Do not lose sight of the fact that the silage ground is the most important place for your slurry for the P&K, and then try to utilize your slurry best to reduce nitrogen then on your grazing ground. So look, with that, I'd like to thank you for this, and I'm going to leave you with a few take-home messages. First of all, look, we need to know what's in our slurry. Get your slurry tested. Adjust then, when you know what's in your slurry, adjust your application rate to suit the crop you're growing, whether it's silage, first cut, second cut, or whether it's just for growing a bit of grass on the grazing block. Apply your slurry to silage and low-index paddocks to maximize its P&K value. Apply slurry using the less to maximize its nitrogen value in the springtime. And in order to do that, take out your soil maps, have a plan, know and identify the paddocks that have those low covers, and have an idea of where that slurry needs to go next spring. It'll also be handy to have that ready to hand for a contractor coming into the yard. So thank you very much.
Okay. Thank you very much, William, for that presentation. And just to remind you, there's some questions coming in. Just to use the Q&A function on Zoom to keep sending in questions. I think the two big points I took from William's presentation there, and we'll come back to the questions in a minute, is 3/4 of the value of slurry is in the P and K. Important to get it back to silage ground. And I think, William, maybe we need to make stickers for these slurry tankers next year. A typical 2,000 gallon tanker next year is worth €80, the contents inside in it. So a huge value at farm level for 2022. So with that, I'm now going to hand over to Dr. Patrick Forrestal. And Patrick has done great work in relation to protected urea and its huge potential to reduce emissions at farm level. Probably the greatest technology we have available to farmers at the minute to reduce emissions at farm level. So Patrick's going to go through some of his work in relation to protected urea and trying to incorporate it in at farm level for 2022. So over to you, Patrick.
Thank you very much, Seamus, and it's a pleasure to join you all this morning. And I suppose first off, I do want to commend each of you for being part of this programme and setting an example regarding how we're going to meet the challenges ahead for agriculture. And I suppose this presentation is going to try and hopefully give you some tips that you can use around your farm and talk about the fit of protected urea. And really, protected urea is a way to get nitrogen on your farm, but it's not the only way. Also, you can grow some of your own nitrogen using clover. So we'll touch on that too. First off, what's protected urea? For some of you, you may be very familiar with it and are already using it, and for others, perhaps not so much. Well, protected urea, it's standard urea as a base, and added to it, it has something called a urease inhibitor. That urease inhibitor mimics urea and blocks the urease enzyme, and in so doing can reduce losses of ammonia. And just like slurry, as William was talking to you about, urea also loses some of its nitrogen as ammonia, and that's nitrogen that you paid for. And particularly in the coming year, that cost is very high. Also, that ammonia that's lost from urea counts towards our national emissions of ammonia, and we have a challenge there to meet our ammonia loss ceiling. The EPA estimate that on average, urea loses about 15.5% of its nitrogen as ammonia. So if you hang on to that nitrogen, you can have it on your farm to grow grass, and that's more valuable than ever in the coming year. Protected urea takes the loss down to around about the 3% level. And that means that simply by adding the urease inhibitor to urea, you've got more effective nitrogen delivered to the plant, which the plant can use. And it also opens up the possibility to cut your rate of protected urea by around 12% versus your standard urea rate. So I suppose the tip from this is protected urea. You can think about it like low emission spreading for urea. But you don't need all the equipment, and it has very high efficacy. So it's a very effective add-on to urea to stop that loss. So you might say, I thought we were doing this because of greenhouse gases. Well, we are. And I suppose we have multiple challenges there. And is there a greenhouse gas saving? So on the one side of the picture here, you can see a tractor spreading fertilizer, and the other side, animals. And on the greenhouse gas picture, we have that challenge there to reduce methane emissions from the animals, and work is undergoing to get the technologies in place for us to do that. But on the fertilizer side, comparing to using calcium ammonium nitrate, we have seen in the research that we can cut the emission factor, or the loss of nitrogen as nitrous oxide, by 73% versus loss from CAN. Now, these are small amounts of nitrogen in the overall scheme of things that are lost as nitrous oxide, but that type of saving, because nitrous oxide is so potent, really counts very strongly in the national inventory of emissions. So on your farm, protected urea, a change of fertilizer form, and clover, whereby you've less reliance on imported fertilizer nitrogen, are solutions that can be taken up right now. And for me, these two go very much hand in hand. So where does protected urea fit on your farm? In the Signpost program, there's a range of different farmers, okay? So there's, I suppose, the animal-based farmers, including dairy farmers, which typically have more straight nitrogen slots in their fertilizer program, and also suckler, beef, and sheep farmers who may have less straight nitrogen slots, and maybe you're using some compound. So the fit here is substituting straight urea and straight CAN with protected urea. There's also some arable farmers in the program, and you might be wondering, how does this fit for me? Well, in the research, we didn't see a big difference between the emissions of nitrous oxide between protected urea and CAN. So if you're already using CAN, you can continue to do that. However, if you are using urea, you can substitute it for protected urea, thus saving ammonia loss. And actually, with the cost of fertilizer now, that makes a lot of economic sense to do that. You also have colleges, and you can refer to the guidance above, depending on what land area you're managing. Pig farmers, you may also have a land area, refer to the guidance above. And also just to emphasize that you have a very valuable fertilizer, and it's very important to spread that with the low emission spreading, because it's got a greater portion of available nitrogen, which is also available to loss, and you can hang on to that using the low emission spreading. And we've got organic farmers, and organic farmers are already growing your own nitrogen, if you like, using legumes. And there's lessons that we can take there that I think can be incorporated into most farms. So while we're mentioning growing your own nitrogen, which reduces your need for fertilizer nitrogen overall, which is something we also need to do to meet the targets that have been set out. And what I'm showing here is data from a replicated blocked experiment at Johnstown Castle, where there's pH in 4 increments going from 5.4 all the way up to 6.9. And this grass ward was overseeded with clover. And you can see here the steps of the stairs increase in yield in that grass clover sward as you march on up in pH. An extra 2.5 tons of dry matter produced there at 6.9 versus 5.4 pH. So I suppose that goes to emphasize the point that David was making earlier about the value of lime. And that's even more so the case where you're trying to get clover going. You might say there's a lot of management with clover, but look, at current nitrogen prices, you're going to be very well paid for that. If you compare back by 75 kilograms N per hectare on a 50-hectare farm, that's almost 10 grand in your pocket. And I suppose, you know, James Humphreys has shown at Hollowhead that he can get back to zero. So now maybe that's a journey to go for many of us, but just by coming back by 75 kilograms, that's the level of money you're talking. So my tip is, if you've got existing clover on the farm, which many of you that may not have been paid a huge amount of attention to, you can give it a boost by liming when you get the chance to do so. And that's a measure that you can take to save yourself some fertilizer nitrogen in the coming year. And if you're establishing clover, you need to lift the pH first. That's the first step. You're going nowhere if you don't do that first. Now, back to protected urea. I suppose the question has often come in, like, is there a yield advantage to it over urea? The short-term cutting and grazing trials didn't see a difference between the fertilizers. So what I've done here is present data from a long-term trial at Johnstown Castle where the same fertilizers are applied to the same plots continually, and this is a 7-year data set. Now, just to focus on the fertilizer effect, the blue line across at 100 is urea. That's the yield of urea set at 100%. For those of you familiar with variety trials, that's relative yield, everything else expressed relative to the urea yield. The red line at the bottom is what the zero nitrogen control grew in the background, anything from 30 to 40% of the urea yield. The purple dots, let's take a look at the can. Can was above the urea line in terms of its yield performance in 5 out of 7 of those years. And protected urea was above the urea line in 6 out of 7 years. So let's just kind of summarize what this looks like in terms of what was the yield advantage for protected urea and can indeed over urea based on the grass that they grew, which is the difference between what the background grew and what the fertilizer grew. So if we exclude 2018, which was a drought year, and nitrogen wasn't the limiter here, it was water, the can grew an extra 9% of grass over urea, and the protected urea grew an extra 13% on average, more than urea. So over the long term, protected urea, it does grow more grass, and I suppose that extra yield is, percentage-wise, is very close to that additional effective nitrogen or effective nitrogen delivered to the plant that I spoke about earlier. Another tip is don't forget about sulfur. This is work from Claire Aspel, who's been looking at response to sulfur on a number of soils. And we see here, moving from the left to the right of the graph, from very fine textured soils to very sandy loam textured soils, about an extra ton of yield produced there for, I suppose, 4 out of 5 of the soils. And the sandy loam soil actually giving a 3-ton boost in these particular soils. So sulfur, you know, it can be important, particularly if you've got those sandier textured soils. And don't forget about sulfur when you're applying your silage fertilizer. Don't rely on the sulfur from the slurry. Claire saw only about 9% of the sulfur in the slurry was available to the plant. And also, clover needs sulfur. So as we pare back on nitrogen, don't forget about sulfur. And you have options there, which are, say, sulfocan, which might deliver 6 kilograms for a 30 kilogram N application, but also ammonium sulfate nitrate, or ASN, and ammonium sulfate. And also, I suppose, on the environmental side, Claire was seeing reduced nitrogen leaching with use of sulfur on a sandy soil. So you might be asking, which products should I use? You know, it's a bit confusing. Well, on our soil fertility website, we keep an up-to-date list of products. Last year, there was 20 products, 6 companies, and there's options there, straight nitrogen and nitrogen plus sulfur. Also an N plus K plus S option, but no option containing P, as you might note. So if you need to use P, use your standard compounds. You know, the supply question comes up. You know, the way to get around that is to order in advance and start asking early for it. Just to finish up on, I suppose, the question of soil health is one that's raised. Because we have this long-term trial in Johnstown Castle, we've been able to look at the bacterial and fungal populations as affected by fertilizer. And in summary, there was no significant difference in bacterial or fungal populations based on the fertilizers that were applied. And look at the scale. We're talking tens of millions of bacteria per grams of soil and tens of thousands of fungi per gram of soil. And I want to credit Aoife Duff and Fiona Brennan for the great work that they've done on, I suppose, understanding those communities. Also, the diversity of the communities there, or the who's who, is quite similar between the different fertilizers. So just to conclude, the fit for protected urea on grassland farms is substituting it for CAN and urea. On the arable cropping, if you're using urea, substitute it here. You can keep going with your CAN if that's what you're doing, but you can use protected urea also if you want to. Because protected urea delivers more effective nitrogen that the grass can use versus standard urea, there's potential there to pull back your rate by around 12%. That was very similar to the additional yield that we saw in the long-term trial of about 13%. Don't forget sulfur. If in doubt around products, consult the online list. And we can't emphasize enough the point that David made around lime, and that's even more important when you're trying to get clover into swords. So thank you for your attention. I'll turn it back to Seamus.
Thank you very much, Patrick. And I'm just thinking from Patrick's presentation there, protected urea, huge benefit, the most environmentally friendly of all the nitrogen fertilizers. And I think the other thing that came out of it there is it's a case nearly of buy 8 tons of protected urea, get 1 free, in the sense you're getting more effective nitrogen use from the nitrogen you're buying. So really, it's the cheapest of all fertilizers. So I think we're actually going to go to the panel now and ask a few questions to some of our speakers. I want to thank those of you who've sent in questions already. Just a reminder that the Q&A function is still working on the screen there, if you want to send in more questions. So maybe just to David, first of all, a question came in, David. If I spread lime now to correct low soil pH, how soon can I expect to get the benefits that you've spoken about?
Well, Seamus, a very good question, and one that comes in fairly regularly. If lime is being spread, so we know that there was a lot of lime spread over the last 3 or 4 months. It's been a very good back end. That lime will start to wash in now with the rainfall that's fallen over the winter, so it's a great time to be spreading lime. And come January, February, that will be after doing probably most of its work in terms of lifting the soil pH initially. And then if we think about ground limestone, there's about 1/3 or 35% to be precise in every ton is fine lime. That works first. And then the other 2/3 works in year 2, 3, and 4. And usually we lime on a 4-year cycle. So ground limestone, it's the cheapest source, very effective and very fast to work.
Okay, so farmers spreading this week, even David, is going to kick in late spring for them to give them that benefit at that stage.
Exactly. And we'll say if you're coming along with protected urea in the spring, there shouldn't be a big issue. You know, there is a no-no out there in terms of spreading urea in particular after lime, because it may increase the emissions. If we spread prior to Christmas, there's usually enough wash in. The soils are wet enough for that fine lime to react, and we can carry on as normal with our slurry and with our urea in the spring.
So Patrick, coming to you, so with the protected urea, that's another positive for protected urea, that you can put out the lime now, use a protected urea in the spring, where you can't use ordinary urea. So another positive as well.
You can, absolutely, and I think that's a positive with protected urea. There's not a big issue there really, and getting your lime right first. Don't let anything stop you doing that.
Okay, just I suppose another question there came in on lime. Just while I'm bringing that one up, David, I think back in the 1970s we were nearly using 2 million tonne of lime per year. We had 7.2 million head of stock in the country in the 1970s. We're at 7.3 today. Why are we only spreading half the amount of lime now that we were spreading in the 70s?
I suppose farmers that generation ago, I suppose, were it's farmyard manure and lime is what they had. Was tried and tested. It done the business, I suppose, in terms of releasing those nutrients that they had stored in the soil organic matter. So there's a huge amount of biology working in our favor there in the soil. However, that biology, and they knew it, can't work in acid, in hostile conditions. It's the very same if we put a delicate clover seed or a ryegrass seed, for that matter, or any seed, into an acid soil. The acid will stop the roots from growing, and hence it's not going to work for us. It's the same thing for the soil biology. So when we neutralize that acidity in the soil by liming, we get the benefits in terms of more persistency and better growth of our seeds, because they have better rooting. And also that soil biology begins to work. It's kind of favorable conditions and begins to break down the nutrients in the slurry, the organic nutrients that are in the soil. We get mineralized nitrogen every year, probably somewhere in the region of 100 to 150 kilos for free.
Okay, so it's free nitrogen, we're getting the lime right. Another question, and I come to William then after that. When applying lime, will the same impact on reducing the emissions, will it be the same impact on mineral or peat soils?
Okay, so very good question. So that study that I showed was on mineral soils. Obviously, they're the ones where you have a lot more stored acidity. So in that mineral matter bound on the clay, you get the acidity, and the acidity comes out and causes the issue in terms of the emission, and it's basically down to the biology that's driving that emission again, right? So when we get into a peat soil, the emission is there as well. You have the carbon. If you put nitrate into that peat soil, when it's wet, you will get nitrous oxide coming out. By liming, we don't lime those peat soils to the same extent. So if we think about the target for a mineral soil, a mineral brown earth, we would lime to 6.3 or above, up to 6.8 for clover. For a peat soil, we would only lime to somewhere between 5.5 and 5.8 because it doesn't have the same level of stored acidity on the clay. There's very little clay, it's full of organic matter. However, we will get a benefit there from liming that soil as well, as long as we keep it within the range that's specified.
Okay, so different ranges for different sites.
Different strokes for different folks or that kind of deals, but different ranges, yeah.
William, a question for you. The value of slurry, William, spread in April versus spreading in January. Can you put a figure on it for us or make a comment on it maybe? So spreading the same slurry in January or in April?
Yeah, so I suppose some of the figures I presented there would show that with a trailing shoe or a dribble bar, it'll deliver 9 units of nitrogen per 1,000 gallons. I suppose that 9 units figure is actually based off trial work that was conducted where the slurry was applied in that March-April period. So I suppose when we are spreading slurry early in the springtime, to be honest, the same rules apply as if we are spreading chemical fertilizer. If we're not going to get a grass growth response, if soil temperature is too low, if soil conditions are too wet, if we're not getting the growth in the grass in early January, we'd expect that we wouldn't get that full 9 units. You do need good growing conditions. I suppose that's one thing we do really need to look at when we are managing our slurry this year, is that, and this is always practical at farm levels, that, come sometime maybe in mid-January or early February and ground conditions are good, we will put out some slurry. But I'd really encourage farmers to maybe, put out maybe just enough slurry to keep them going. And then, as time goes on and as the growing conditions improve, maybe delay the slurry a little bit where possible. And then, then there'll be better opportunity for the nitrogen that's in the slurry to be uptaken by the grass.
So rather than emptying the tanks on the 13th of January just because you can, put out a little to carry over and keep it to when you get better growth from the conditions.
Exactly, yeah.
Okay, so the farmer in control of the slurry rather than the slurry in control of the farmer.
Yeah, exactly.
Patrick, maybe just come back to you there, question maybe we covered already. Just when you're putting out the lime, how many days after can you use the protected urea?
Yeah, so this is a question that's come up a good bit, and I've actually done some trial work where we put the protected urea directly onto lime, and it didn't increase the losses putting it directly onto lime. So we went that close to it. So the urease inhibitor and the protection that's on the protected urea seems to be making it safe to apply quite close to lime. And I suppose the thing to remember also is, days is one thing, but what's the weather as well? So, as David talked about, that fine active lime, if you spread it and you get some rainfall, a lot of that's starting to wash into the soil. But there doesn't seem to be an issue there, and the protection seems to be doing the trick. So don't hold back from spreading lime because you're worrying about protected urea.
So we're saying we're getting a better effective nitrogen use, up to 12% than ordinary urea. We can put it out, put out protected urea after lime, gone out a couple of months beforehand, and we'll also act the same as can for the summer with a lot lower emissions. So it's really win-win-win. We're talking here, protected urea pretty much all around.
Yeah, it's ticking those boxes for us.
And I know some of our colleagues in Moore Park have done a couple of case studies with dairy farms, with 100% can to 100% protected urea, reducing total emissions at farm level by 7 to 8%, was huge for technology that's actually going to benefit the farmer's pocket.
Yes.
Yeah. Okay, William, this one to you. Just will the nutrients in slurry be better from open tanks, towers, lagoons than cover tanks?
Well, I suppose there's two sides to that. When you have a covered tank, there's generally less water in the tank, so you'll have a more concentrated slurry there'll be a higher P and K value in your kind of cover tanks. And that's, I suppose, that's what we saw in our kind of small study, that in the cover tanks, there was higher P and Ks in it and higher nitrogen as well. So because the fact that there was less water in it. So typically those types of slurries, like what I think people should be aiming for is maybe to try and get that type of slurry onto their silage ground where there's high requirements for P and K. And if it's a case that they can't get it to their silage ground, maybe they really have to be conscious of the rate that they use on the grazing platform. Instead of going with 3,000 gallons, maybe 2,000 will be enough to supply the nitrogen that they want to grow. As well, I suppose that's the P and K side of it and the content. The other side to it then though is with our kind of lagoon type slurries, the amount of nutrients in them will be diluted, and that's very important for P and K for spreading for silage ground. However, nitrogen works slightly differently to that. There might be less nitrogen in the lagoons because it's more watery, but the nitrogen is actually used very efficiently. The actual amount of water that's in it is actually helping to physically wash the nitrogen into the soil so that it's not sticking to the top of the grass, and not being exposed to being evaporated or burnt off or black light.
More readily available in a way, William.
Exactly, yeah.
Now, question here, and I'll throw it maybe to I need a three of each, everyone you want to take it. With fertilizer prices high for the spring, is it okay to hold off on the compounds until later in the year with the hope there'll be a bit of a price drop? I don't know which of the three of you, maybe so David.
Maybe if I start off, we can't tell, I suppose, in terms of the price drop. Part of that question, and look at, we will all be very hopeful that fertilizer will come back, but at the moment it doesn't look likely, I suppose, in terms of either the first or second round this spring. However, when we get into that question a little bit more from the science standpoint, we're better to apply the P in particular, phosphorus in particular, is better spread in that March window. So more than likely that second round on many of the early farms, or maybe the first round on a dry stock farm. And the reason being is when the soil is cold and damp, the research shows that phosphorus actually drives early growth. And when I say early growth, it's after Paddy's Day, usually growth takes off, and we need a well-timed phosphorus, either through slurry or through a compound, right before that to drive that energy for that growth, and it'll help to pick up the nitrogen on the way. So it's a very important question. We don't want to apply it too early because, especially on a hungry and index 1 or 2 soil, the soil will take that phosphorus and lock it away into storage. So we want it well-timed, March window, second round or first round on a dry stock farm, and that'll drive the growth.
Okay, so maybe a compound like 18612 or something along those lines.
Perfect. In terms of a grazing compound, a P is to K, 1 is to 2, so 18 to 612, so 6 is to 12, or even a 10-10-20, 10 is to 20 is ideal for grazing. Whereas on a silage type situation, you want something with a lot more K in it. So no 730.
So you were saying earlier rather than later. And just on that one, Patrick, protected urea, it does come with some K, some of the products. How would you incorporate the phosphorus David is talking about into maybe with protected urea?
Yeah, it's a good question. So we don't have protected urea options with phosphorus. So I suppose going back to what David said, getting the phosphorus in there with your compounds at the appropriate time, and that early or mid-spring phosphorus, delivering that with your standard compound is the way to go. And for example, if you use something like 18612, you can get on a decent amount of phosphorus there and perhaps open up more straight nitrogen slots in a program where, for instance, you've delivered phosphorus using 18612 rather than relying on multiple splits of 27.2.5 or 24s, for instance.
Okay, so yeah. Stronger type compounds you're talking about there.
Yeah.
Just one or two final questions there. Just on heavy impermeable type soils with high rainfall, how much is leaching a problem with regard to lime and chemical fertilizer applications? Which you want to take that one?
Well, I can start, Seamus, in terms of the heavier the soil is, the less the leaching, right? So that's in a nutshell.
For P-type soils locking it up.
Yeah. So if we have a a light soil or a sandy soil, we're going to get a lot more lime moving through that. And probably then we need to be on the ball in terms of the soil tests and applying more lime more regularly in terms of that program. Overall, the heavier the soil at the same time will take more to fix it, to lift the pH initially, but then it will hold itself because there's less leaching going on. And by far the biggest user of lime, or the biggest, I suppose, way that lime is moved out of the system is with rainwater and leaching.
I'm going to ask a final question to Patrick, and after that I'm going to ask each of you for 2 simple tips that you want farmers to do for 2022. So Patrick, just one here for you. How does a tillage farmer justify using protected urea, the switch with the additional cost of protected urea over urea?
Yeah, it's a good question. So look, with the inflation of fertilizer prices, I suppose, going through the roof, the relative cost of that add-on for the protection it is essentially paying for itself now. So if you work out the numbers there, if you were saving 10% of nitrogen that might go off as ammonia, and you can do the numbers on what that's worth depending on your rate. So now, because it's delivering more effective nitrogen to the plant, and because that nitrogen is so valuable, actually protected urea can be more cost effective than urea in a lot of situations in the coming year.
So it's very cost effective for the farmer. So
Yes.
David, maybe 2 points, if I was giving you just to summarize maybe to our audience in relation to soil fertility lime for 2022.
So my two tips would be to measure and manage, as I said in the final take-home message. So take out your soil tests or get new soil tests updated, and then manage accordingly. Look at your lime and look at your P and K, where to put your P and K.
And not to take the holiday with the P&K.
And not to take the holiday. The holiday can be a short-term win in terms of the pocket for a long-term loss in terms of economic sustainability and production.
William, if I was to ask you for 2 points.
Well, I think that what farmers need to be doing, particularly this year and going forward, is they really need to know what is in their slurry. First and foremost is get their slurry tested, know what's in it. And when they have that information, that's going to be powerful information for them then to be able to target where does that slurry need to go, to silage ground, to grazing ground, and then help them to inform what the application rate should be to match the crop demands.
Okay, so get the slurry back out to the silage ground is that a big one as well. I think hopefully maybe the Signpost programme that we will be doing some testing of the slurry for the Signpost farmers as well. Patrick, on protected urea?
Yeah, that's great. So look, I suppose more generally, we've seen that agriculture has been under the microscope every time you turn on the radio this year on emissions. So getting protected urea usage up is an important issue for farmers, I suppose, to show progress that we're reducing the emissions. And that conversation is going to come up every year now. So get protected urea usage onto your farm. Supply has been an issue. Talk to your merchant early about getting your hands on it, and also don't forget about sulfur. There are protected urea products with sulfur available there. So those are my 2 tips.
Yeah, I think on that one, on the Climate Action Plan for 2021, we're expected to use 65% of our can as protected urea by 2030. We're using 5% protected urea at the minute, 22% urea. If we could just change all that to protected urea straight off, we're halfway to our target, which is a huge start to the overall thing.
Yeah, and look, that's really important for us to show progress there and to take, I suppose, the pressure off while the technologies around methane reduction are developed.
I think for the Trevi this morning, all your technologies are very cheap. Lime, protected urea, probably the low emission soil spreading is the most expensive technology. The early spring spreading, again, it costs nothing. It's about timing and management. So look, on behalf of myself, I'd like to thank our 3 speakers, Dr. David Wall, Dr. Patrick Burchill, and Dr. William Burchill and Dr. Patrick Forrestal for 3 very good presentations and a good questions and answers this morning. Just to remind you to log back on again at 11:45 for session 3 of the Signpost Assembly, where we'll be doing covering carbon farming, sequestration and methane, trying to reduce emissions at methane at farm level as well. So on my own behalf, on behalf of the Signpost team, I'd like to thank our 3 speakers for this morning, and thank you very much for joining us.